Good day, everybody, and welcome to today's webinar on PFOS in the environment, sources, behavior, remediation at infrastructure and manufacturing waste sites. This is the first of a three-part series. Today's webinar is going to be hosted by Stefano Marcanetto of Golder Associates with special guests from Environment Canada and Health Canada. Stefano is a senior environmental engineer and associate in Ottawa, and he's Golder's global PFOS practice leader. He has over 10 years of experience with site characterization, risk assessment, and remediation at PFOS contaminated sites, including airports, military bases, firefighter training areas, manufacturing facilities, and landfills. He works across North America and overseas. But first, before we get going, a word about this webinar. We're going to go for about an hour today. There should be time for questions at the end, so please feel free to type them in as we go using the question or chat button on your screen. I'll go over the questions with the panelists at the end, and then we'll try to get to all your questions. And so now, over to you, Stefano.
Thank you very much, Guy, and thank you everybody for attending. As Guy mentioned, this is going to be the part one of a three-part webinar series, and I'm just going to provide a brief introduction before leaving the floor to our colleagues from the Canadian federal government that will provide a perspective on the contaminated sites work that the federal government is doing in relation to PFAS. So just a brief introduction first. If there is anybody in the call that doesn't know what PFAS are yet, this slide is for you. It's a class of synthetic compounds that include thousands of chemicals, all man-made, and they are all formed with carbon chain with fluorine attached to those chains. And as you probably know, the carbon-fluorine bond is the strongest bond in nature, and this makes these compounds very persistent, resistant to degradation, and the sources can still be active a long time after the last use of PFAS. Some of these compounds are also bioaccumulative, some biomagnify, and there is also suggestive evidence that two of the PFAS compounds, namely PFOS and PFOA, have a carcinogenic potential. In terms of chemistry, this, as I like to call it, is the PFAS family tree. And you can see at the very top that the big family splits into two, the perfluorinated compounds and the polyfluorinated compounds. The perfluorinated compounds are those molecules for which of the carbon-nitrogen bonds on the alkyl chain has been replaced with fluorine. And the polyfluorinated compounds are the ones that still have some carbon-hydrogen bonds. And then if you follow the orange part, the perfluorinated compounds are divided in two categories, of which of interest for most of the discussion is the perfluoroalkyl acids, or PFFAs. And these PFFAs are broken down into two main families, the carboxylate and the sulfonates. And these two families are the ones where most of the compounds that you hear about belong to, such as PFOS and PFOA. And the PFCAs and the PFSAs, so the carboxyl and the sulfonates, are also named terminal PFAS because these compounds cannot really biotransform in the environment. Whereas everything else that is not orange on this slide is actually called precursors, and precursors under certain environmental condition can actually biotransform to the terminal PFAS. And it's speculated that the PFAS family, the entire group, includes more than 3,000 compounds. And currently, commercial laboratory analyze for about 30 of these compounds. So that's about 1% of the entire family only. As you may have heard, the regulatory framework has been changing very rapidly, and it's different in the various jurisdictions across the globe. Some of the trends that we have been monitoring started with the development of drinking water criteria for PFOS and PFOA. Despite many jurisdictions having this criteria, the range in concentration is quite different among the various jurisdictions. New York just recently proposed 10 parts per trillion for PFOS and PFOA in drinking water, and Canada currently have a criteria or a guideline that is like 600 and 200 for PFOS and PFOA in drinking water as well. On top of that, there are differences between the federal criteria, such as the ones in Canada or the US, and the state criteria in the states, or the provincial criteria in Canada. Some jurisdictions went a step further and started to develop criteria for other PFAS, different than just PFOS and PFOA in drinking water, as well as criteria for some other PFAS in other environmental medias. There are many fish consumption advisories throughout the globe. And it's nice to see now that we actually have a trend where we try to limit the disposal of PFAS both in landfills and wastewater treatment plants. There is the example of Australia, where they actually prescribe the maximum concentration of PFAS that you could have in solid waste in order to determine what type of landfill you can send that material to. And there are the example of Vermont and Michigan, slightly different between each other, but where in one case they indicate what type of concentration of PFAS you can have in landfill leachate in order to send it to a wastewater treatment plant. And if you are above those limits, you actually have to pre-treat the leachate before sending it for treatment, or where they put the onus on the wastewater treatment plant to meet the discharge criteria, but then go after all the sources of wastewater that they're receiving and impose to those sources pre-treatment if necessary before they receive it, so that they can actually meet their discharge criteria. And then in some cases, we see jurisdiction going to the very source of the problem, as you will hear a bit more later. Canada is proposing the removal of some exemptions for the use and the import of selected PFAS, including some precursors. And you may have heard about Proposition 65 in California, where right now it prescribes to businesses in California to warn employees about any exposure to PFOS and PFOA. But starting in July of this year, will actually preclude any of those businesses to actually discharge any concentration of PFOS and PFOA in water. So that's quite restrictive, and there are lots of fines if those limits are exceeded. So that provides a little bit of framing to the follow-up discussion. Now I'm going to turn the floor to Rita and Darcy. So Darcy Longpre is an environmental scientist with Health Canada. She's based in Montreal. She has over 20 years of experience in contaminated site assessment, risk assessment, and guidelines development. She's currently the Health Canada representative on the CCME Contaminated Sites Working Group, and has been involved with the development of several guidance values, as well as documents for PFAS. And then we have the pleasure to also have Rita Moros. She's an environmental scientist with Environment and Climate Change Canada. She has over 25 years of experience in contaminated site assessment, remediation, and research. And she's the regional coordinator for the Federal Contaminated Sites Action Plan in Atlantic Canada, as well as the co-chair of the Federal PFAS Working Group. So over to you, Rita.
Thanks very much, Stefano. Hopefully everyone can hear me okay. So I guess just to outline the presentation that Darcy and I are going to give today, after a brief introduction to some of the challenges posed by PFAS, we're going to present a history of the Canadian regulatory context. However, the bulk of the presentation will focus on PFAS as they relate to federal contaminated sites. And this will include the early challenges that we faced in identifying and managing these sites, the development of guidelines to assess them, and also describe some of the other guidance documents that are available, as well as some ongoing research activities. Then finally, we'll present some of the ongoing challenges that we are facing and some next steps with respect to PFAS site management in Canada. So as Stefano has already explained, PFAS compounds are very persistent and stable in the environment. They often have both hydrophilic and hydrophobic properties and can often be found at the air-water interface. As a result of these unique properties, there is the potential for very long dissolved plumes in groundwater and also long-range transport in the air, especially with the shorter chain PFAS compounds. And to date, there's limited full-scale remedial options available in Canada. There's thermal technologies such as high-temperature incineration and also sequestering type technologies such as activated carbon, but other commercially available technologies aren't quite there yet. In terms of sources for PFOS and PFOA in Canada, there has been no known manufacturing of PFOS or PFOA in Canada. So unlike our neighbors to the south, we don't really have the same issues associated with the actual production facilities of these chemicals. It's more as a result of accidental or deliberate release or long-range transport. However, we did import them as polymers until it was banned in 2008 for PFOS and then in 2016 for both PFOS and PFOA. They were then incorporated into the manufacturing of various products such as paper manufacturing, textile and clothing manufacturing, carpet and carpet care products, and also oil and water repellents. So the releases in Canada are most often related to the result of wastewater effluent, consumer and industrial manufactured items, deliberate discharge such as emergency response at crash sites and fire training exercises, and long-range transport. So now I'm going to very briefly touch on the regulatory context that we use here in Canada. So in 2006, the Ecological Screening Assessment Report was released by the government, and this report concluded that PFOS, its salts, and its precursors were entering the environment in a quantity or concentration that under those conditions have an immediate or long-term harmful effect on the environment. It also concluded that PFOS is persistent and is bioaccumulative. Under our Canadian Environmental Protection Act, if chemicals are deemed to be harmful, persistent, and/or bioaccumulative, regulatory instruments are often used to mitigate the effects of these chemicals. As a result, for PFOS, the PFOS regulations were issued in 2008, which prohibited the manufacture, use, sale, offer for sale, or import of PFOS and also products containing PFOS with a limited number of exemptions available. In 2009, PFOS was added to the Canadian Environmental Protection Act's virtual elimination list. And on the international front, it was also added to Annex B of the Stockholm Convention, which is an international agreement that is to protect human health and the environment from persistent organic pollutants. In 2012, a screening report for PFOA was released, which was very similar to the PFOS report that was issued in 2006, with similar conclusions such that PFOS has long-term effects, is persistent, and has bioaccumulative properties. In 2016, the Prohibition of Certain Toxic Substances Regulations 2012 was amended, which included both PFOS and PFOA. And it also includes prohibitions on the manufacturing, use, sale, offer for sale, or import of PFOS, PFOA, and other toxic substances. However, there are some exemptions to all of those. Currently, there are going to be considerations made for further restrictions on these compounds. For example, the current regulation allows for up to 10 parts per million PFOS in aqueous film-forming foam. However, the updated regulations are actually considering the removal of this allowed residual such that essentially no PFOS would be permitted in AFFF. The consultation of these proposed changes is ongoing till February 18th. If you would like to make any comments, the consultation document is easily found on the website, or you can ask me after and I can provide it to you. On the international front, PFOA is likely to be added to the Stockholm Convention just in a few months at the upcoming April meeting in Geneva. So now we're going to switch our attention and focus on the federal contaminated sites aspect. So our Canadian Constitution sets out specific responsibilities and jurisdictions related to land management. The federal government has jurisdiction over federal lands, while the provinces and territories have jurisdiction over sites on their own lands and also those on private properties. As we learned earlier, AFFF is a significant source of PFAS, and due to the operational requirements at both airports and military bases, fire training exercises and fire training areas have been a priority for the federal government in terms of site assessment. For provincial and territorial sites, some sources could also include landfills, application of biosolids on agricultural fields, various effluents, including municipal wastewater, industrial effluents, and also they may have some private, smaller fire training areas. So much of the work to date done at federal sites has been funded by the Federal Contaminated Site Action Plan, or better known as FCSAP. This is a 15-year program, started in 2005, and it will end in 2020. And approximately $4.5 billion has been allocated over the last 15 years to this program. And the goal is to reduce risks to human health and the environment from federal contaminated sites and those associated federal liabilities. We tend to focus on the highest priority sites, which have been defined as Class 1 sites, defined and by the National Classification System, by the CCME. Also, we tend to focus on pre-1998 sites, so we focus on the legacy sites that we have in our inventory. There are plans underway to extend this program after 2020, so we'll see in the next couple of months if that is going to happen. So it was around 2010 that the Contaminated Site Program began to deal with PFAS sites as they were coming forward and being submitted to us by both National Defence and Transport Canada primarily. And what we concluded was that there was a lack of field protocols. We were learning that many of the standard protocols that we always followed when we used good collection techniques to get our samples were not really appropriate for PFAS sampling. For example, Teflon tubing, glass jars, all these were not recommended for PFAS sampling. And at that time, no new approaches were standardized across the board. There was actually no standardized analytical methods available. Everyone was using modified versions of other methodologies, but we didn't, no one seemed to be using a standardized methodology. There was also limited laboratory capability. At the time, there was one, maybe two commercial labs that were available to our federal colleagues to get their work done. Sometimes the confidence in the data was a bit low. Split samples were often outside acceptable quality assurance, quality control boundaries. And the biggest thing was there was a lack of guidelines of benchmarks against which to compare our data that we were generating. So rather than each department try and figure out some of these issues on their own, we brought them all together, the key stakeholders, and we created the PFAS working group. It was originally the PFOS working group, and we've morphed into the PFAS working group. It includes such federal departments as National Defence, Transport Canada, and the National Research Council. Also expert support departments, including Health Canada, Fisheries and Oceans, and Environment and Climate Change Canada, and also Environment Canada's Science and Technology branch. And this just provides a forum for identifying data gaps, sharing research, looking at successes at other federal departments, sharing lessons learned, and prioritizing our needs. One of the first things that was identified was we need criteria. We're generating data and we don't know whether we have a problem or not. So that was one of the first things that was on our to-do list, was to try and get some criteria in place. So now I'm going to turn it over to Darcy, who's going to talk a bit about criteria.
Thanks, Rita. So, I think there's a slide missing, but that's okay. I'll just say this quickly, that in this section, we're going to discuss how the federal government has addressed the need for the numerical values or criteria that are necessary to assess sites that are potentially contaminated with PFAS. And this will include a bit of background on the terminology used to describe the various types of values and the separate And then there will also be separate sections to describe how we derive the values to protect the human health and the environment. So on this slide, my intention is just to highlight the fact that there are a lot of different values out there at the federal level, and it can get pretty confusing. You don't need to memorize all these acronyms. I just want you to be aware that SV means screening value, and it refers to interim values, and that QG means a quality guideline, and that's a published value that would be available for general use. Although we commonly use the term criteria to describe these values, the federal environmental quality guidelines are not actually regulatory values, and therefore they're not actually criteria. Although there may be some jurisdictions, some provinces or territories that would adopt these into their regulations, which would essentially make them legally enforceable standards or criteria. And also under FCSAP, they do endorse the use of the CCME values, the soil quality guidelines, when managing contaminated sites. So they're not, strictly speaking, legally enforceable, but they are recommended. The terms that you might see floating around that refer to environmental quality values include soil quality guidelines and soil screening values, federal environmental quality guidelines, which are for a variety of additional environmental media that outside of soil, and drinking water quality guidelines or drinking water screening values. Generally, the development of the nationally endorsed guidelines, which would be the soil quality guidelines and the drinking water quality guidelines, takes many years from start until publication. And in the case of PFAS, there was the need to develop values much more quickly, as Rita mentioned, in order to provide site managers with tools to manage their sites. And therefore, values to protect ecological and human receptors were developed on several fronts simultaneously. Screening values were developed using less stringent review processes and potentially less data than the guidelines would require, and that would allow them to be available more quickly. Oh, Stefano, can you go back? I'm not quite there yet. Thanks. Because they're based on less stringent reviews, they were only made available to the Federal Contaminant Sites Action Plan, and that would help us ensure that those using them could be kept up to date of changes to those values more quickly. The soil quality guidelines are published by CCME, which is the Canadian Council of Ministers of the Environment, and they're endorsed by all the provinces, territories, and the federal government. The CCME brings together all those different levels of government to work on development of these values. But these values also require more background documentation and review, and they can take a lot longer to publish. They are applicable on all federal sites and also any other contaminated site where the local jurisdiction would allow that. And finally, federal environmental quality guidelines are developed by Environment and Climate Change Canada to meet needs for guidelines that are not currently developed by CCME. And they include guidelines for additional ecological receptors and media. And they're also applicable for environmental monitoring and assessment and other needs, other areas where you might need these type of values. And we'll provide more details on these in this section coming up. Okay, you can change now, Stefano, thanks. So what are the screening values? The screening values are very similar to environmental quality guidelines that are published by CCME. They use the same methodology to develop the values with the same default parameters and assumptions, and then anything like similar, those types of values. They also develop them for the same pathways and land uses as prescribed by the CCME protocol for the development of soil quality guidelines. However, as you'll see here, they're done more rapidly and they undergo less stringent reviews, and they sometimes have lower data requirements. The screening values are available currently for 8 PFAS for the protection of human health, and for PFOS and PFOA only, they are also available for the protection of ecological receptors. And that's because there was not enough data to allow the development of guidelines for ecological receptors. Okay, next one, Stefano. The soil and drinking water quality guidelines are developed in collaboration and approved by the provinces and territories, as well as the federal government. The CCME coordinates this guideline development, as I mentioned earlier, and as well as the review and the publication. And contrary to the screening values, the guidelines go through several levels of review before they're published. They're freely available in English and French, and they're always accompanied by a thorough scientific criteria documentation. At this time, SQGs are under development for PFOS and PFOA, and drinking water quality guidelines were published for these two substances in December of 2018, so you can find those online. Next one. Next slide, Stefano. Thanks. I don't want to spend a lot of time on the methodology of guidelines development because that's could take us down a rabbit hole. But this equation is just simply to highlight the principle behind guidelines development and identify what types of data are needed to derive the human health guidelines. So quickly, to describe the equation, you'll see the SSVHH, which is on the left-hand side, and that's your soil screening value. It could also be the soil quality guideline, depending on what is applicable, what data you're working with. In the numerator, you'll find two chemical-specific variables that are used to identify the safe exposure limit. So the TRV is the toxicological reference value, and it's a toxicity-based lower limit of human toxicity to protect against adverse effects. And then the EDI is the estimated average background exposure to a substance that every person would be expected to be exposed to. So this does not include exposures from contaminated media or unusually high exposures, such as hobbies or occupational exposure. The denominator provides an estimate of exposure from a site. And this is, for the guidelines development, this is based on default assumptions that are outlined in CCME guidance. So I just want to briefly present the chemical specific data that we use to derive the soil values for PFAS. The TRVs for PFAS were generally based on laboratory studies in rats and mice. This is because epidemiological data, while it supported many of the findings that we saw in the rat and mice data, they were inadequate to derive the dose response curves for PFAS. And out of the 9 PFAS that we evaluated, including PFOS and PFOA, we only had sufficient data to derive 5 TRVs. I've indicated here which were the critical effects for those 5 substances for which we could derive the TRVs. And then for the other PFAS that we derived guidelines for, or soil screening values for, we used the TRV for PFOS or PFOA as a surrogate in that derivation process. We chose PFOS and PFOA because they were the substances for which we had the most robust data. Next slide. And here we'll just see the other chemical specific data that we used in this derivation. We have the estimated daily intake, or the EDI, and that's based on available data that we had for air, food, drinking water, and dust. So these are background concentrations that we found for those media. Data on these media was still fairly limited, and we were only able to develop EDIs for PFOS and PFOA. We did not have enough data on the other substances, the other PFAS. So the EDIs for those other PFAS was set at 0. For the background soil concentration, or the BSC, that was also set at 0, but this was based on a decision around the fact that PFAS do not occur naturally, and therefore they should not be found in the environment. We know that we can find PFAS in almost any place that we've tried to measure them, but normally they are anthropogenic and they should not be found as a natural background. So these values, combined with the default values identified in CCME, allow us to derive the soil values using the equation that I showed you in the previous slide. And that's very similar to a risk assessment for those that are doing risk assessments. Did we skip a slide here, Stefano? I guess.
Hey, Darcy.
Oh, sorry, it's me. Yes, Guy?
Sure, just before we leave this slide, I see it says do not cite or distribute plastered across this thing. So is that a warning to our audience that if they do a screen capture of this, they should not be quoting these values?
That's right. That's because, as I mentioned, most of these values, and I'll go over that in this slide, most of these values are interim values. So it'd be premature to be citing or distributing them. There are a few that are available or will be available soon, and you can find those in other sources. So you could always contact Health Canada or Environment Canada if you want to be using these values, and then we can give you some guidance on that.
Okay, thanks very much.
So this is up to date as of now, as it's basically there for a screenshot of the soil and drinking water values that we have derived for PFAS at the present federal government. Presently, none of the soil values have been published as soil quality guidelines, so they're still considered soil screening values. However, at the present moment, they're the same values that we are proposing as soil quality guidelines for PFOS and PFOA. They are subject to change, however. The PFOS and PFOA drinking water quality guidelines were published in December, so those are free for use and can be found that the background documentation is all available online. However, the other values are all soil screening values, and they could change, and it's quite possible that we change the nomenclature, that they will be called something different than screening values in the future. The TRV column, so the third column, refers to the TRVs that we use to derive the human health protective values, and then the final column presents the draft PFOS soil quality guideline, which has also been used for screening previously. And this is not yet published, but it has been out for public review, so people might have copies of that document, draft document. And then you'll notice that there's a row for PFOS plus PFOA, and I'll go over that in the next slide. So we can change Stefano. So since PFAS, as we've mentioned earlier, Stefano has mentioned, and so has Rita, that they're generally found as mixtures on sites. We have looked into the question of additivity with regards to the toxicity of these substances. Unfortunately, the data are very limited for the majority of the substances, so this is an area of research where much more work is needed. However, for PFOS and PFOA, the two substances for which we have the decent data sets, there is significant evidence that the critical effects are the same. And for this reason, Health Canada suggests that additivity be addressed when we find PFOS and PFOA together. We provided a simple method to account for the potential additive effects of these two substances when screening for them in environmental media. The ratios of the concentrations of the substance over its screening value are summed, and if the result is less than or equal to 1, then we consider that the result is acceptable and that there should be no human health risk associated with those samples. Concerning fish consumption, at this point we can't identify a value that would be protective of human consumption of fish. Studies have identified high concentrations of PFOS in waters that have met surface water guidelines or surface water standards, and fish tissue as well as fish tissue guidelines. Ecological food chain values, so we'll see those in the coming slides that are coming, they're not protective of the consumers of fish. So for this reason, we cannot assume that fish living in waters that meet guidelines are safe for consumption. So if fish consumption is suspected at your site, then site-specific risk assessment is definitely recommended. And I think with
Darcy, that previous picture, just to clarify, it wasn't real obvious what that's a picture of, but I take it that's fish drying on a rack, is it?
Yes, that's fish drying on a rack. That's not somebody's laundry, no.
Okay, thank you.
Yeah. So I think Rita's going to present the our ecological aspect of the guidelines development now. So I'll pass it over to Rita.
Thanks, Darcy. Yeah, so I'm going to run you quickly through the Federal Environmental Quality Guidelines. So what are these FEQGs? They're benchmarks against which to assess environmental quality. They're ecotoxicologically based, so they don't consider human health aspects. So generally, if your data is below an FEQG, then there's a low likelihood of adverse effects in the environment. They're voluntary, they're not regulatory or any sort of legal limits. And in addition to contaminated sites data, they're also useful for evaluating monitoring results and assessing risk management options. They're derived following the CCME protocols for the various media, Right now, there have been about 12 FEQGs developed and are available online. In addition to PFOS, there are FEQGs for vanadium, bisphenol A, triclosan. Anyway, they're all available online and easily found. So for the PFOS guidelines, they were developed for 4 receptors or media. We developed a guideline for surface water, fish tissue, wildlife diet, including mammals and avian species, bird egg residue. When the FEQGs were first posted for review, you may recall that soil and groundwater were also part of the suite of guidelines included in the FEQGs. CCME has decided to adopt those values and champion the publication of those as CCME guidelines rather than FEQGs. So the soil and groundwater are now being published by CCME. They've been out for review by the CCME and hopefully will be published in 2019 as national guidelines. Next slide. So I'm not going to walk you through the derivation of all those guidelines, but just quickly, I'll show you the surface water guideline and how it was developed. It was based on a species sensitivity distribution approach. We used data with no effects and low effects endpoints and also chronic studies. So we picked data available for 5 fish species, 5 aquatic invertebrates, 8 aquatic plants, and 2 amphibians. And we plotted up the data, and it was the protocol suggests that the 5th percentile is where the guideline is chosen. So the next slide, Stefano. Here's a species. Here's the species sensitivity distribution that was plotted up for PFOS. So the no effects and low effects data is plotted. The concentration of PFOS is along the bottom versus the proportion of the species and taxa affected is along the y-axis. So the concentration of PFOS at the 5th percentile and right where it intersects, where the arrow is, and you drop your line down and you can see just before the number 10 there, that's 6.8 micrograms per liter. So that's the hazard concentration at the 5th percentile. And hence, that's the Federal Environmental Quality Guideline for surface water. Next slide. So here's the Federal Environmental Quality Guideline as a whole. It does say interim. I apologize for that. That should not say interim anymore. They're just Federal Environmental Quality Guidelines for PFOS. So you've got your water, fish tissue, your wildlife diet broken down into mammalian and avian species, and your bird egg residue. And it was published just in June of this year. So in addition to contaminated sites, the Federal Environmental Quality Guidelines are also used to assess general environmental monitoring data collected by Environment Canada and other monitoring agencies. So for example, to provide long-term perspective on PFOS and lake trout, archived samples from 1979 right up to 2014 were analyzed from the Great Lakes. So here's some data from the Niagara and Port Credit areas of Lake Ontario, some of the trout data. So what's interesting here is you can see that the PFOS concentrations in Lake Ontario showed an overall increase between 79 and 2000. Then it started to stabilize, and then it actually started to decrease after 2002, which also coincides with the year 3M phased out its production of PFOS. So the concentrations in fish tissue actually never exceeded the guideline. The guideline of 9,400 nanograms per liter is way off this chart. At the very top of the graph, it couldn't be plotted. So you can see the fish health was always well below fish health guidelines. However, there are instances where it was above the both the mammalian diet and the avian diet at points along the timeline there. So there could be a concern for fish eating wildlife, not necessarily the fish itself. So, okay. Just another example of where these FEQGs have been used. This was a 2017 paper. Water samples were collected from 3 areas in Ontario, water adjacent and downgradient of a fire training area, an urban area, and then a rural area. And you can see again, the surface water value is in excess of 6,000, whereas the highest concentration on this graph is approximately 700. So again, below the surface water guidelines, but certainly a difference in areas between an area with a fire training area compared to a rural or even an urban area. Next. So this slide basically sums up some of the screening values and guidelines that are available for PFAS contaminated sites. At this point, only drinking water quality guidelines for PFOS and PFOA are available for use outside of federal departments. All the other values are really to be used only by federal sites unless you consult with the provincial or territorial government that you're working with if these numbers would suit their needs. So you can see the column heading indicates the type of value that we're presenting. In the first column, you'll see the PFAS for which values have been developed. The Federal Environmental Quality Guideline for PFOS with the little earth there is completed. The PFOA value we're working on, and same with the soil quality guidelines for both PFOS and PFOA are still in draft. So you'll note that PFOS and PFOA seem to be the most common PFAS for which guidelines have been developed, and that's just not in Canada, that's also elsewhere around the world, and that's just due to the fact that the bulk of the data for PFAS have historically focused on these 2 substances. So you can also see that very few substances have ecological values, and again, it's because that the data just isn't available, and for creating any of these guidelines at this time to meet the requirements for the guideline development, they're not of sufficient quality or quantity for what we need to create guidelines at this time. Okay, Darcy, over to you.
Thanks again, Rita. Okay, so I'll try to wrap this up in the next 5 or 6 slides here. We'll provide you with a quick overview of some of the other documents that the federal government has prepared and to help assess and manage PFAS sites. So if we can go to the next slide, Stefano. This is a list of some of the guidance documents that have been prepared in Canada. So we've got, the first one is the FICSAP interim guidance on the management of sites containing PFOS and other PFAS, and that's available to the federal departments. We have quite a few documents that are still internal to the federal government, but if upon request, they can probably be sent out to people. We have the Federal Environmental Quality Guidelines for PFOA. As Rita mentioned, they're under development right now. The Soil Quality Guidelines are also being developed for ecological and human receptors, only for PFOS and PFOA. The PFOS SQG is almost complete. It's gone through public review already, and we're addressing the comments on that at this time. And the PFOA SQG, the ecological values are still being developed, but that is also something that should happen in the, well, let's say not near future, but near future in guidelines terms is at least a year out, or possibly more. The Transport Canada and the National Defence Department have developed site assessment and sampling protocols for PFAS. And some of the provinces have been developing guidelines. BC published their guidelines for soil and water last year in 2017. I guess it's a bit over a year now. Next slide. Excuse me. This is another document that Health Canada has recently developed, and that's to help with human health risk assessment at PFAS contaminated sites. And it's based on Health Canada's existing human health risk assessment guidance that was put out in 2010. And the thing that's unique about this document is that it's quite short, which is nice, and it's generally presented as lists or bullet form that highlights the aspects of PFAS which may require special attention or that are different from the approach used in most human health risk assessments. So what does that mean? For example, the framework contains sections that discuss the high mobility of PFAS, the influence of precursors on characterization of PFAS at sites, and also the analysis of PFAS, sampling methods that you need to use to avoid contamination, and the potential for PFAS accumulation in fish. And we've provided the address here if you want to try to ask for a copy of that document. Additionally, we're involved, Health Canada and Environment and Climate Change, as well as a few other departments are involved in some research. Health Canada is currently supporting research to help identify and confirm toxic effects of PFAS. And that's ongoing on both individual and mixtures of PFAS. Prior to this, we've been working on data that is using only one individual substance. So it'll be interesting to get some data on mixtures for human health toxicology. The research is on both animal and human cell lines and will help us identify the modes of action for PFAS. And that should help us with improved confidence in our TRVs and potentially identifying a bunch of new TRVs in the future. We're working with 28 individual substances at this point and 6 different mixtures. Next slide. And on the environment side, in 2011, Environment and Climate Change Canada's Emergency Science and Technology section began to reach out to various partners to undertake a study to assess PFAS remediation options. The collaborators included Canadian federal government stakeholders, academia, US partners, including the Department of Defense, and several private industry representatives, which include laboratories and environmental consultants. The objectives were to identify and evaluate the most promising remedial technologies for PFAS sites, technologies to address both contaminated water and soils. They evaluated several technologies, including ion exchange resins and activated carbon. After in-house studies and bench scale evaluations, a field trial was designed and is being undertaken in Cold Lake, Alberta this fiscal year. And there have been several papers and publication issues as a result of this 5-year study. And you can contact Rita if you want some more information on that. Next slide. So in summary, we're going to present some of the ongoing work and challenges, future work at the federal government that the federal government is involved in or that we're following in order to improve contaminated sites management. Next one. So you might recognize this slide from earlier. Rita presented this, showed you what our challenges were early on in the federal departments when trying to address PFAS sites. I'm showing it here again so that we can show you where we're at as of 2019. So we can see that in 2010, we were faced with data gaps, a lot of data gaps analytically and also as well as with the guidelines development, and that we've made significant progress today. We're now able to carry out site assessments thanks to the field protocols that Transport Canada and the National Defence have developed, and the standardized analytical methods developed and tested by several laboratories and in interlaboratory trials. The number of analytes that can now be measured is also increasing, along with the data confidence that we're getting out of this. We've also shown today that guidelines development, while it's a slow process, has progressed significantly. Both the federal government and some of the provinces are developing or have developed guidelines for a variety of PFAS substances. Next slide. And we're not done. We have a lot of challenges still ahead of us. Since the PFAS are a mixture, they provide a lot of unique challenges because of their chemistry and the lack of data that we have on the for chemical mixtures as opposed to individual substances. We're looking at large-scale remediation technologies. They're not readily accessible at this point, so that is something that we really would like to see more focus on. We're still focusing on assessment and delineation at most of our sites. Site management guidance is less developed than the sampling and the screening guidance, so that's another area that we want to work on. previous site work may have involved moving or mixing soils, and this makes delineation and characterization very difficult at some of our sites. That's also due to the PFAS fate and transport, which are very difficult to describe. So site characterization is still an area that needs more research. And there's also an issue with the short chain PFAS that are being considered as substitutes. They were generally considered less toxic than the long chain PFAS, but they're also a lot more mobile than the long chain PFAS. And we don't fully understand the implications of this on our sites when we're doing our site assessments. And finally, now that the other jurisdictions, so the provinces and territories, as well as municipal governments, are addressing their non-federal PFAS sites, we need to consider the potential for off-site migration and the needs of those governments as well. Next slide. Well, next steps. Site managers must be particularly careful when they're dealing with PFAS sites or sites where substitutes may have been used. Some of the PFAS substitutes that have been used and have also been shown to cause their own problems. For example, many of you may have heard of Gen X, which has been used at several sites as an alternative. If we look at the water supply around some of these areas, such as Wilmington, North Carolina, where they've been having problems with Gen X for over a decade, and the legal and environmental issues are ongoing. Another one is perfluorohexane sulfonate, which is initially assumed to be less toxic due to its shorter chain length. Now it's been shown to be more mobile and has also been added to the Stockholm Convention, which aims to restrict use and eliminate releases of persistent organic pollutants into the environment. As we mentioned earlier, new research is needed to better understand the fate and transport of PFAS, their vertical delineation, and their ecotoxicology and toxicology. Some of this work is ongoing and will help us inform research into new treatment and risk management options. And those are also under development, the treatment and risk management options. Given how active this research is, it's important that those managing PFAS sites validate that they're using the latest guidance available whenever they're dealing with one of these sites. Next slide. I just want to, Rita and I want to acknowledge some of the partners that have been involved in this research at the federal level. So we have the Department of National Defense, the Wing Command Group, and Environment and Climate Change Canada. There are several departments that were involved. There's the National Guidelines and Standards Office, which developed the guidelines, Emergency Science and Technology, which are involved in a lot of the research, the Persistent Organic Pollution Control Unit, the Contaminated Sites Division, Corporate Science Services and Finances Branch. At Health Canada, we have the Healthy Environments and Consumer Safety Branch, which includes the Contaminated Sites groups as well as the Drinking Water Group, and the Regions and Regulatory Operations Branch, which are involved in a lot of the expert support for contaminated sites. And finally, the Federal Interdepartmental PFAS Working Group needs to be recognized for all the work that they've done in supporting our research and our work. Next slide. We've just got two slides here that we'll just go right through, but you'll just see that you have access to the references that we've used in this presentation.
Well, thanks very much, Darcy and Rita and Stefano. Fascinating, actually. I'm going to ask Stefano to sort of go over the plans for the next two sessions of this webinar series. And while he's doing that, please feel free to type in your questions using the Q&A button, or you can type them in on the chat function. See, we've already got a question and a chat question, which we'll address right after Stefano. You tell us what's happening next Tuesday and the following Tuesday.
Sounds good. So session 2 will be next Tuesday, January 22nd, and section 3 will be the following Tuesday on the 29th. And we are going to share some of the experience that we learned at Golder in our decade-long work on PFAS globally. and present some of the case studies where we're going to talk about similarity and differences between PFAS sources as well as impacts for AFFF impacted sites versus manufacturing versus waste sites. We can share some insights on the best practices around source characterization as well as plume assessment and differentiation of those multiple sources that we talked about. And then we're going to cover probably on January 29 something about the remediation strategy as well as what's emerging out of those for good decision making from all the custodians as well as site managers.
Awesome. Just a comment, I sure hope, Darcy and Rita, that you're able to join us for those next 2 sessions, because I'm pretty sure you're going to have a few questions for Stefano about his experience and details for, you know, accurate site characterization, etc., and how he applied the standards and how he's going to apply these new criteria that are coming up. And in the meantime, while the questions are being typed in, I had a question here for Darcy. Well, I have a few questions actually. I'm going to ask one and then I'll go to some of the ones that are typed in. But my main question has to do with I guess let me see here. It relates to the state of knowledge we have today and where we're going, and how do you benefit from some of the work being done in, let's say, jurisdictions outside of Canada? Are you collaborating with the Americans, the Australians, the European Union on sharing data and recognizing there's some challenges that don't just apply to Canada, but they're probably global issues? And another comment, actually, I know it sounds like Canada's actually, if you want to call it, early adopter of recognizing this issue. Federal government back in 2006 was pumping out documents. This is probably way before many other countries had even recognized the problem. So that well done, Canada. But are we keeping up the search, so to speak? Maybe Darcy or Rita, you can answer that.
Darcy, do you want me to start?
Sure, go ahead.
Yeah, I guess certainly on the world stage, Australia's been a leader in this, and we keep in very close contact with the Australian government, or the Australian government, also consultants that are working in Australia. So we do reach out to them, I would say weekly. We have some sort of exchange with them in terms of what's going on and what they're doing down there. So the US EPA, it's kind of one of the few topic areas that in terms of even guidelines and stuff, in some parts, Canada has been a bit out front. I think with the ITRC PFAS group that's got together now, and they're publishing their fact sheets and that kind of thing. So things are moving along there. But I do keep in touch with a contact down at the EPA just to monitor things down there. But
I'm guessing you're not talking to them much right now with the shutdown.
Unfortunately, no. The woman that I've been dealing with, Linda, I haven't been able to get a hold of her, so I haven't really reached out to her to bug her lately. But anyway, you know, we do recognize there's no sense reinventing the wheel on these things, and we do try and keep in touch with our international colleagues and see what's working for them and what we maybe want to try here, or more importantly, not to try, just to see. Darcy, do you have anything to add to that?
I don't have a lot to add. Rita's really the best person for that, being on that interdepartmental group. I am not sitting on that group, so I'm not in the day-to-day of that. On the guideline side, we do share when we're asked, and when we're developing guidelines, we do scour the literature and we do share things whenever we're asked for it as well. Although we try to focus on Canadian data, we do always take a look at what's out there for other jurisdictions, and especially the US, Australia, and Europe, which are more similar to us. So yes, we do keep in contact with them.
Interesting. Well, a follow-up question from a colleague of mine in Sao Paulo, Brazil, actually. So it is a very international issue, but He's asking, this is a technical question about fate and transport, which is probably more of a subject for the upcoming webinars, but he's asked if PFOS in groundwater can cause an increase in the solubility or mobility of other organic contaminants, such as petroleum hydrocarbons or chlorinated solvents. And actually, I might even flip that around. You know, for example, at a firefighting training area, can the petroleum hydrocarbons or non-aqueous phase, is it possible that could act as another medium to sort of spread the PFOS around and increase its mobility? So one way or the other, is this a situation that causes concern? Any comments from Darcy or Rita or Stefano?
Stefano, do you want to take that one?
Sure, I can take that one. The issue is complex, so there isn't a straight answer to that. As Rita and Darcy mentioned, there is some R&D still going on in terms of characterization, but the point is quite on the mark. Like the issue of co-contaminants is a big issue. We've been looking at that, whether it's petroleum hydrocarbons or chlorinated solvents, and there can be interferences at various levels. Like you have at the NAPL phase, but you also have potentially down gradient of the source area where you may have hydrocarbons already sorbed to the aquifer material, and then the PFAS comes through, and some compounds, depending on the chain length, may sorb more to those aquifer material or hydrocarbon molecules that are there. Some may sorb less, and some may actually displace the original hydrocarbon or solvents molecule that are in there. So that's right. A hot topic of research. I don't think there is much outcome of that, other than the fact that we're being observed is that typically when you have elevated concentration of hydrocarbons, typically the PFAS are moving faster than in the absence of those.
Right. Darcy, a different question here, but before I go into some other questions, one that popped up into my mind. In developing these guidelines for protection of the environment and human health, you mentioned that PFOA and PFOS, you assume there could be an additive effect, so you come up with a more conservative guideline. And on that additive effect, I mean, if the precursors are also an issue and we don't have much data for them, is it possible that we should have, there may be even a more stringent guideline coming down in the future once this research is done, looking at mixtures with precursors?
Well, I won't stick my neck out to say that there's going to be a lower guideline, although I think that it's definitely possible. The work that we're looking at with Health Canada on the mixtures, and then also looking at it from a gene point of view, that should help us identify really commonality in how they're acting on a toxicological level. So hopefully that'll help us kind of work with these as a class of substances, and then that may lead to lower guidelines, but hopefully it'll be a more robust justification for those guidelines too.
Right. Okay, that makes a lot of sense.
We don't really have good data for anything except PFOS and PFOA. So we can't really infer that there is an additivity or that we're going to be able to address these as a class completely.
Well, I guess we'll just see where the research takes us. Somebody's asked here a question that I think I know what the answer is in British Columbia, but if you test for PFOA, what are your obligations? If someone's doing a landfill study, whether it's on a federal property or a federal jurisdiction or provincial, if you test for PFOS, I'm guessing you're probably going to find it. Is there an obligation to do anything once you find a value, if it's over one of these guidelines, or is it up to you?
Well, strictly speaking, it's up to you. But I think that most jurisdictions will have some form of due diligence requirements that make it so that they would be hard pressed to ignore it. So depending on your jurisdiction, they're going to have different ways of approaching what type of risk assessment they need to do, or what type of guidelines they have to, or criteria they have to compare their data to, et cetera, moving forward. So it would really depend on the jurisdiction. But legally, there isn't really an obligation, but if there are any kind of risks that are identified and you don't act, you can definitely be held accountable for your inaction.
Right. No, that's a reasonable answer. I think in British Columbia it's a little bit different, but I'm not going to go into the nuances of how we wade through our own regulations here. Somebody's asked about I think it was about the CCME. What was the question here? Are there? Let me see. Here's a question. In the absence of published CCME criteria, what's the current recommended federal PFOS criteria for groundwater? Well, I take it is there no CCME guideline for groundwater right now for PFOS?
I guess I can take that one too. No, there is no guideline right now for groundwater. And in the drafts that we're coming out with at CCME and in the soil screening values, there are also no groundwater guidelines for human health. There are some guidelines for protection of aquatic life, so that's a surface water quality guideline that would be being fed by groundwater, or there's also a livestock watering guideline. I'm not fully apprised to how those were derived. The surface water one is the Federal Environmental Quality Guideline. Those are the guidelines that Rita was presenting. So it's derived in a bit of a different way than the soil quality guideline. Groundwater component generally is developed. And that groundwater model that is used by CCME to develop groundwater guidelines doesn't work with the PFAS at this point. It's quite a bulky model, but there are some of the parameters we don't have adequate data, so we can't run that model. So there won't be any groundwater guidelines in the upcoming SQGs unless something big happens in the next few months. So for now, there are a few values for the ecological side, like I mentioned. So it would be livestock watering and freshwater life, which is a surface water value driven by groundwater. And on the human health side, we'll suggest that people take groundwater samples and compare them to drinking water guidelines.
Right.
And yeah, and on the eco side, when the CCME does issue their numbers, like Darcy said, it's going to be based on the surface water number because these things don't degrade or attenuate as they move. The surface water number is going to be set, as far as I know right now, equal to the groundwater number. So 6.8 micrograms per liter is the current surface water number in the Federal Environmental Quality Guidelines. And that's what CCME is considering adopting for its groundwater number as well. So from an eco perspective, groundwater will be 6.8. Also in the interim advice document that's available to federal contaminated site owners, all these guidelines are summarized in that interim advice document. If anyone would like a copy of it, they could ask me for it. They are noted in this document that just came out at their call. They're referenced as draft, but it's what we've got right now.
Okay, thanks. Just wrapped up with one question. Someone's asked if there's any obligation for composting facilities in Canada to test their compost against PFOA guidelines, PFOS guidelines for composting facilities. It's probably something that's as part of due diligence. I'm pretty sure you should be testing for these if your composting is including, for example, wastewater treatment plant sludges or something, right?
I don't know if anybody has an answer to that one. I don't really have an answer to that. I'm not aware at all of how composting facilities are regulated.
Yeah,
right, and that would be under provincial or territorial jurisdiction for the most part. So each province or territory would set those types of guidance and guidelines for what quality for compost is required.
Right, and you're right, Guy, like it falls under the provincial jurisdiction as well, and primarily if they accept waste from wastewater treatment plant, that will be the main trigger, especially because then they're going to be spread on agricultural fields as biosolids, right? So the issue will just skyrocket from there.
Right. Okay, well, I think it's time to wrap up. We've gone over an hour here. I just want to remind people to don't forget to sign up for sessions 2 and 3. next Tuesday and the following Tuesday. This webinar itself, I believe, will be available to you for a limited period of time for those of you that have signed up. Not sure about the slides. People are asking about the slide deck. I'll have to discuss that after the webinar with our participants here, and we'll let you know. So in the meantime, thanks everybody for joining us, and we look forward to seeing you again in the very near future. As a matter of fact, tomorrow our GeoEnviro Pro Talks series resumes tomorrow with Riders Up, Gilly, and myself, and we can do some more follow-up with you then. So thanks everybody, and goodbye.
Okay, thanks.
Bye.
Bye.
Thank you.
Bye-bye.